Hello everyone, welcome to this video. In this video we will see the popular question, that is maximum subarray, or it is also written as largest continuous subarray sum or maximum subarray sum in a given array. So basically we are given an integer array numbers. Find the contiguous subarray containing at least one number, okay, which has the largest sum and return its sum. So we have to find the subarray with the largest sum and return its sum. So in this array basically we are given any negative to positive integers. So like in this array we have -2 1, -3 4, -1 2 1, -5 4. So in this array the maximum sum is 6, and that is by forming this subarray, that is 4 -1 2 and 1. So if we add 4 plus 2 plus 1, so that comes out to be 7, and -1, that is 6. So this is our largest sum. Okay, so we need to solve it in ON solution, ON complexity, time complexity, and I will show you basically the naive approach and the ON time complexity solution. So if you solve it simply, so it will take ON square time, because if we use two nested loops, so basically we will have to initialize a variable, that is sum, okay, that will store our result, and we will initialize it to the minus infinity. So we will initialize two loops for nested looping. So I will iterate from 0 to n, okay, and j will iterate from I plus 1, that is one index ahead of I, to the n, okay. So that is our n minus 1 actually, so n minus 1. So we will keep track of a temp variable. We will create temp variable for a particular I, and we'll keep adding the elements in that temp variable and see if it is greater than the sum that we have to output. It is greater than the sum of all the subarrays, so we will output that. So it is basically using two loops, so it will take ON square time. So it is a good solution to start with in an interview. So the interviewer will ask you to optimize the solution, and it takes O1 space complexity. So for the better solution than this in ON time, so we have a algorithm called as Cadence algorithm. So in this algorithm we can optimize the solution and make it ON time complexity and keeping our space complexity as constant. So I have written the pseudo code here. So in this we have to initialize two variables, that is max ending here. So max ending here will store our value which we are computing for the particular like index, so that will keep that, and max so far will be our result which we have to return, maximum of the whole array. So we will use one loop only, that will be for from 0 to n minus 1. I will iterate from 0 to n minus 1, and I will show you these steps by running them on this code. So basically we have two variables. I have written this max so far. This is our result variable that we have to return, and I have initialized it with minus infinity, and this is our maximum ending here. Maximum ending here is basically a temporary variable or a current variable. So in this array I have taken the example from LeetCode. So this is our input, and output should be 6, and output should be formed by 4 -1 2 and 1, as we have seen earlier. So this is our array, and these are our indexes, okay, 0 1, and I will start from 0 to n minus 1, that is this position, and at first index I will iterate, and we have max variable and we have initialized it to 0. So we will add the first element, that is array of 0. So that is -2. We will add -2 to this. -2, it will become -2. So we will check. We have executed this condition. Now we will check if max so far is less than maximum ending here. So yes, max so far is minus infinity. So it is less than -2. So we will change the value of, I will just indent it. So we will change the value of maximum so far to -2. Okay. And now we will check if maximum ending here is less than 0. So we will initialize it to or set it to 0. So yeah, it is less than 0, so we will set it to 0. Basically we are doing this to like this may be not our potential subarray, so we need to find new subarray. So we have found this, its sum is -2, so we may not include this in our subarray, so we are setting it to 0. So now again I will iterate to the next element, that is 1, index 1. So index 1 element is 1, so we will add we will come into this condition, and we will add plus 1 to 0, so it will become 1. So we will check if max ending, so max so far, that is our final variable, is less than 1. So yeah, max ending here, so yes, -2 is less than 1, so we will set it to 1. Okay, so now we will check if maximum ending here is less than 0. So it is 1, so it is not less than 0. We won't execute this condition. Now we will again iterate I to the next element or next index, that is 2. So array of 2 is -3. So we will add -3 to this maximum ending here. So we have not changed its value to 0 because it was greater than 1. So now it will become 2. So we will check, oh sorry, it will become -2. So we will check if maximum so far, that is 1, is less than maximum ending here. No, it is not less than, so it is -2. So if we don't include this element, so we are, and this element we are getting one sum at only one index, so we may not include this. So we will check. So now we will come into this condition, that is if maximum ending here is less than 0. So yes, it is less than 0, it is 2. So we will set it to 0 because this may not be the potential subarray that we are searching for. So now I will again iterate to the next element, that is 4 or index 3. Array of 3 is 4, so we will add this 4 to this index. So now the value will become 4. So now we will check in this condition if max so far, that is 1, is less than 4. Yes, it is less than 4, so we will change its value to 4. So it will become 4, and we will check if max ending here, that is 4, is less than 0. So no, it is not less than 0. So this may be our potential subarray. So now without resetting its value, we will go to the next element, that is -1. So I will come to index 4, that is having value -1. So we will add to this -1, so it will become 3. So now we will check max ending here is less than max so far is less than max ending here. No, 4 is not less than 3, so it will stay as it is. And we will check if max ending here is less than 0. No, it is 3, it is not less than 0. So we will go to the next index. So we have included this element in our array. Okay, so now we will check at this index, that is array of 5 is 2. So we will add 2 to this 3, so it will become 5. Now we will check if max so far is less than maximum ending here. So yes, it is less than, 4 is less than 5. So we will set it to 5. Now we will check if max ending here is less than 0. No, it is not less than 0. So I will iterate to next element, that is 1 or index array of 6. So we will add 1 to this 5. Now we will have value, that is 6. So 6. So now we will see max so far, that is our final variable, is less than 6. 5 is less than 6, so we will set it to 6. Now we will check if it is less than 0. No, it is not less than 0, that is max ending here. So now I will iterate to the next element, that is 5 -5. So now we will add -5 to this. Okay, so -5 plus 6, that is 1. So we will get -6 minus 5 is 1. So we will check if it max so far is less than that. No, it is greater than the max ending here. So now we will check this is not less than 0, so it will stay as it is, and I will iterate to the next element, that is 4, and at index 8. So we will add 4 to this, so it will become 5. So we will check max so far is less than the max ending here. No, 6 is greater than 5. So we have got our final output, that is we will return the maximum so far. So we have got the maximum so far. So this was basically the solution using O and time and O1 space. So it was easy question. So Cadence algorithm is not easy, or not it is easy, not that much difficult or difficult to understand. It basically uses one loop and 2 variables to show the maximum and the current values, and this was it. And this was a naive solution. So I will show you the code on LeetCode platform, and I will also share the code in the description. So please download the code or for your reference, or you can watch it for your reference. So this was the question, and I have written the code in C++. So here is the code. I will uncomment it. Now you can see we have got an vector of integers here. I have initialized 2 variables, that is the answer, that is our final result or output, to the -infinity, and the sum, that will be our current sum. So we will iterate from for I is equal to 0 to I less than numbers, okay, dot size. So now we will keep adding the current element to this value. So we will check if answer, that is max so far, is less than the max ending here. So we will I have basically, instead of using if or else loop, I have used only the max inbuilt function. So we will set it to the max value out of the both, and now we will check if the current value, that is our max ending here, is less than 0. So we will set it to 0 for the maximum of. So that will be it. So we will finally we will return the result, final result output. So let's see it works or not. Okay, so it got accepted. Now we will submit the solution and see. So yes, it got accepted, and it is faster than 84.19% of solutions, and it takes less memory than 43% 0.65. And that was it, guys. And this question also has a different solution, that is using the divide and conquer approach. If you want to me to make video on this, so please comment down below. So that was it, guys. So do like this channel and do like this video, subscribe this channel and share this video please if possible, and do comment down below for more videos like this if you want, and do subscribe, guys. Thank you guys for watching.